So this video is for the distance and displacement problems, speed and velocity that we were working on in class. I already did the first two with you in class. The first one, if Paul throws the football 50 meters in 3 seconds, what is the average speed of the football? Remember, you've got all your formulas up here. Speed right here is distance divided by time. So then it's 50 meters is our distance. 3 seconds is our time. 50 divided by 3 is 16.7. And since it's speed, you need units, but no direction. The next one, if it takes Cassie 3 seconds to run from the batter's box to first base at an average velocity of 6.5 meters per second, what is the displacement she covers in that time? So they're trying to find displacement. Here's the formula for displacement. Time times velocity, or multiplied by velocity. Displacement, time multiplied by velocity. So our time is 3 seconds. Our velocity is 6.5 meters per second. So if you multiply those two together, I'll write below here 3 seconds times 6.5 meters per second, then you're going to get 19.5 from meters, because it's a displacement is a measurement of how far, and then you need a direction because it's displacement, so I put from the batter's box. The next one, Muhammad ran 500 meters from a swarm of bees at an average speed of 6 meters per second before he dove into a pond. How long did he run? So in this case, long means time. If it was a distance, they would probably say how far did he run. So if we're looking back up here, we have 500 meters, 6 meters per second, and we want to know how long. So we're looking for time. And so, oops, I'll make that a little thicker. Time. And if we look up here to our formulas, time is distance divided by speed. So time is distance divided by speed. And we said our distance is 500 meters. That's how far he ran, or 5,000 meters, sorry. And our speed is 6 meters per second. So when you divide those, you get 833.3-ish seconds. We're looking for a time, so we have to do seconds. Here you go. If Nico races his Ford F-150 truck down east route on Route 1 for 2,560 meters in 60 seconds, what is his average velocity? So we're looking for velocity. And velocity is, if you look back up there, is displacement divided by time. So our displacement is 2,560 meters, and it's east. I'm just going to put a little E there because that's our direction. And our time is 60 seconds. And if you divide that on your calculator, you should get, and I'm just rounding here to the nearest tenth, to 42.7 meters per second east. We have to put our direction in there because it's a velocity. Okay. Miguela rides her motorcycle at an average speed of 20 meters per second for 500 seconds. How far did she ride? So if we're looking for how far, so a distance, and how do we know it's not displacement? Well, there's a keyword in there. They're saying speed and not velocity. So that's going to give us distant. That'll let us know that we're looking at distance and not displacement. So on this one, we want distance is speed times time. So we'll write that down here because we've got room. her distance, or her speed is 20 meters per second, multiplied, she went for 500 seconds. So when you multiply those out, her distance is 10,000 meters. And we do not need a direction on that one because it's distance, not displacement. And next, Anoop. Backstrokes at an average speed of 8 meters per second. How long will it take him, so how long is time, to complete the race of 200 meters length? Okay, so we're looking at time, and which time are we looking at? Well, if they're using speed, we want the time that's got speed in it. So when we look up here, this time has speed in it. That time has velocity. So we know it's time equals distance divided by speed. Okay. So this one, the distance is 200 meters. Our speed is 8 meters per second. So when you divide that out, you get 25 seconds. And there you go. Valentina's Subaru Forester was detected going faster than the speed limit of 60 kilometers per hour. How many kilometers per hour would he have to been traveling over the limit if he had traveled 10 kilometers in 0.1 hours? It says, if you want to express this value as a velocity, what other information would you need? So there's a lot going on here. So it said it was going faster than the speed limit of 60 kilometers per hour. So that's just showing you, so this 60 kilometers per hour is just telling you the speed limit. But it's saying he had traveled 10 kilometers in 0.1 hours. So how many kilometers per hour would he travel? So what's his velocity if he had traveled 10 kilometers in 0.1 hour? So you got to kind of read that one carefully. So we're looking for velocity. And there's two parts to this one, but we'll do this first. And that is our displacement. Sorry, this is sloppy there. Divided by time. And his displacement was 10 kilometers. And he traveled that in 0.1 hour. So he was traveling, when you divide that, at 100 kilometers per hour. Well, if the speed limit was 60, he was going 40 kilometers per hour over the speed limit. So we have this answer, which is how fast he was traveling, and this one over the speed limit, 40 over. So there was two parts, okay? And it said, what other information would you need on this one? A direction. Since it's velocity, we need a direction. So that's another part to this question. Lots going on there. Kirsten's calculations involving lobsters found that the average lobster, when placed on the ground, was able to cover 20 centimeters in 5 seconds. What was the average speed of the lobster? So the speed is distance divided by time. And we know they covered 20 centimeters in 5 seconds. So they were going 4 centimeters per second. Pretty speedy lobsters. Okay, there you go. There's your key.